We have seen how to calculate the minimum of 2 integers and 3 integers. So a natural question is, how do we generalize this to n integers? I mean, clearly we don't want to have to write a new function for each value of n. So we're going to focus on the min3 function, and we're going to focus particularly on line 2 of the min3 function, and we're going to try and get inspiration from this line. How did we calculate the minimum of 3 integers? Well, if you look at the statement on line 2, what we're saying is the last step that we do, the outermost function, is the minimum of 2 values, right? And one of those values is x2, which is the last of the 3 given integers. The given integers were x0, x1, and x2. So the last step that min3 does is finally it calculates the minimum of 2 integers, one of which was the last of the given integers. So we'll use this idea to generalize and think about what the minimum of n integers are. Now I am numbering my integers from x0, so I will have n integers x0, x1 up to xn minus 1. And borrowing from this idea, we will say that the minimum of these n integers is finally the minimum of 2 integers, one of which is the last of the given integers, which is xn minus 1. Now, what about the first argument to the min2 function? Once again, let's go back to our min3 function for inspiration. We had said that the first argument was the minimum of x0 and x1. So if we want to generalize this idea to n integers, clearly we would have to have the minimum of the other integers that were given. So a minimum of the other integers will basically translate to this, minimum of x0, x1 all the way up to xn minus 2. Now notice something important here. We are basically trying to write an inductive definition. I'm trying to define the minimum of n integers in terms of the minimum of n minus 1 integers. Now, mathematically, this isn't perfect because a function like min has to have a fixed number of arguments. So I can't have on the left-hand side, I can't have n integers, and then in the right-hand side, I have n minus 1 integers. But even though this isn't mathematically perfect, I hope you can get the idea of what we are trying to do. Now, when we are going to try and convert this into code, we will just have to find a way of expressing this in the C programming language, but the idea is hopefully quite clear. Now, there's one thing that's missing, of course, in any inductive definition, and that is the base case. And we could choose the base case when n is 2, because then it's just the minimum of 2 integers, and we know how to write that. But for this piece of code, I'm actually going to choose the base case as 1. So if I'm only given one integer, that would be x0, then that number x0 itself is the minimum of all the given integers. So I'm going to use that very simple base case n equal to 1. So let's copy this definition to our next slide and try and go from this definition to the C code. So here is what the final answer looks like. And the first thing I want you to just sit back and appreciate is, wow, that's simple. I mean, it's only 7 lines of code. So let's understand what these lines are. So the first line, we're saying min is a function that returns an int. And it takes 2 arguments, right? The first argument, there's a parameter n, which is an integer. And then there is this second parameter, x square bracket n. So we have to understand what this notation means. We're saying that x is an array of n integers. So an array you can think of like a list, right? So the elements of this list are going to be numbered starting from x0. So on line 3, you see that if n is 1, we are going to return x0. This is the only element in an array of size 1. So the elements are numbered starting from 0. So x0 is the first element. So this corresponds to our base case. Otherwise, we're saying that we have more than one element. In that case, we're going to use this inductive definition and return the min2 of min n minus 1 comma x. So we're saying take the same array x. That's the second argument of the inner min function. And the first argument is n minus 1. So we're saying in that array, in that list of n elements, just consider the first n minus 1 of those and tell me the minimum of those. So that is my recursive call. So you notice here I have fixed that technical problem that we had said earlier in the mathematical definition. In both cases, my min function takes two arguments. The first argument is a number, and then the second argument is an array of that length. So here we're saying take the array x, but only consider the first n minus 1 elements of it. Take the minimum of those. That is your first number. And then your second number is xn minus 1, which is the last element in the given array x. So once again, please remember that if you have an array of n elements, the first element is called x0 and the last element is called xn minus 1, and we put these numbers inside square brackets. These numbers are sometimes called the index of the array. So the array, the first value is at index 0 and the last value is at index n minus 1. So this is the whole function. And now I want you to see how this works, and we'll visualize this code on Python Tutor. So here we are. We have a piece of code. We have a main function in which I have declared an array of 3 elements. So this happens to be the syntax for defining an array of size 3 inside curly brackets. Then you just list the elements of the array. So I have an array of 3 elements, 1, minus 3, and 2. And then what I'm saying is print the minimum of these 3 elements, the minimum of 3 elements in this array. So of course, visually, you can see that the minimum is going to be minus 3. So as usual, up here in the box, we're expecting to see the value minus 3 when we're finally finished. And we have our min2 and min functions exactly as we have seen in the slides. So let's go ahead and start stepping through. Notice that right now in the main, we're in the main, and we have this array which is uninitialized. These values are question marks. We're just about to put some values in that array. So when we hit next, we are about to execute this line. And then when we execute it, we see that the array has values 1, minus 3, and 2. Now I'm going to show you something very interesting. So we're going to call the min function, and the min function takes 2 arguments, 3 an array. It has 2 parameters, n and xn. So we know what we're expecting. We're expecting this 3 to get copied into the n. And we can assume that analogously, we are expecting these values in array, namely 1, minus 3, and 2, to get copied over into xn. So maybe the picture that we're expecting when we hit next is that the focus will shift to the min function, and the min function will again have an array like this where we have copied the data from the main array into the min array. But here is what actually happens, and this is extremely important to understand, and I will ask you to go back and review this the material on Python Tutor to make sure you follow this step. It's a very, very crucial step. Here we are about to call the min function with the arguments 3 and this array 1, minus 3, 2. Here is what happens. We have jumped to the min function, and right now in the visualization it's saying I don't quite know what n is. It's a question mark. I don't quite know what x is. And when I click next, you will observe what happens. N is 3 and x is a pointer. X is simply pointing to the array that was already declared in the main function. So what we're saying here is that when we pass an array as an argument to a function, we don't copy all its values. And the reason C is doing this is it's saying, I want to save some time. Instead of copying all these values, and remember the array could be very, very big. In this case, it's a very short array. It's only 3 elements. But if the array is millions of elements long, this could be a very, very expensive copying process. So instead, C says that if you give an array as an argument, then I am not going to copy those elements. I'm simply going to point to the original array. So in the min function, you are welcome to look at the 0th element of this array, but we will just point you to the 0th element of the original array wherever it was. So by doing this, by setting up these pointers, we actually save a huge amount of time. Now sometimes as programmers we really want to copy the array, and in that case we have to do this copying in another way and we have to do it manually. So a critical point to note here is that when you pass an array as an argument to a function in C, then the default behavior is it doesn't copy the elements of the array, it merely points to the original array. So in the function that you have just called, all you have is a pointer or a reference to the original array. But you can still access the elements of that just as you would before. So for example, if you look at what's happening on line 7, we're talking about x square bracket 0. And since x is pointing to this original array, x square bracket 0 really would be the value that lives at position 0, which in this case is 1. So with this important point in mind, let's start tracing the code. So we have n equal to, the test on line 6 is n equal to 1. If n is equal to 1, then we want to return x0. But we are looking at n equal to 3. So we're going to skip past this if condition. We're going to come to the else. And in the else, we have to return this complicated expression. And just like we saw with min3, the way we evaluate this is we first evaluate the inner function. And then once we have that value, we can compute the min2 of that answer and xn minus 1. So the first thing that's going to happen here is we are going to make a recursive call this time to the min function. And what are the arguments? N minus 1, where n is 3. And if n is 3, n minus 1 is 2. So you'll see when I hit next, we have another copy of min. Once again, right now, the parameters don't have values, but when I hit next, n will become 2. This n is 1 less than this n because the recursive call was called with n minus 1. And so when in this function n was 3, in the recursively called function n will be 2. But we gave it the same x. So this x is pointing to exactly the same place as the previous x was pointing to. So both these x pointers are pointing to exactly the same array. Let's proceed. We are now in this min, not in this min. Here n is 2 and we're asking is n equal to 1? No, it's not. So once again we will come to the else, and once again we will first evaluate the inner min before we can evaluate the min 2. Here again, since n is 2, I'm going to make a recursive call with 2 minus 1. So in this case, I will call min with n equal to 1. And this time, x is again pointing to the same array as before. Now here, line 6, the condition n equal to 1 is true. So n equal to 1 is true, so I have to return x0. Well, as far as this min function is concerned, what is x? It's the same array as up here. And what is the 0th element of this array? Well, that is 1. So on line 7, we are going to return x0, which is a 1. Now, where are we going to come back to? Well, who called this min function? This min function was called by this min function. And why did this min function make this call? Well, it was trying to compute the min 2 of two things. So now when we come back to this line, we will know what this answer is. It's going to be x0, which is 1. So this min function, the last of the min functions, this bottommost one, is about to finish. We are quitting this function. You will see that this function will disappear. Its answer is 1. And now we're back inside this min function, and we know that this part, this first argument to the min 2 is 1. And what is the second argument? Well, the second argument is x of n minus 1. And what is n? N here is 2. So what is x 2 minus 1? What is x 1? Well, x is this array and its 1th element. You can see these indices are written in small numbers up at the top. The 1th element is minus 3. So we're now going to call the min2 function with the first argument as 1 and the second argument as minus 3. And you will see this when we hit next. We are now in the min2 function, the code for which is up here. But since I can't keep the code and the picture in the screen at the same time, I'm just going to focus on the picture. We have already seen how the min2 function works. It takes two arguments, x0 and x1. And we know that x0 is 1 and x1 is minus 3 because that's the values that we called it with right here. Now, what is the minimum of these two? Well, obviously it is minus 3 is the smaller of these two. We already know that the min2 function works correctly. So I'm just going to hit next until we come back from the min2 function and we have returned a value. So this copy of min, which was called with n equal to 2, has figured out that this part was 1 and this part was minus 3, and the minimum of those two is minus 3. So this min function is ready to return minus 3. So we return that, and then we are back in this copy of the min function where n was 3. And why are we here? Because we had just called min with 2. And the answer to min with 2 we know now is minus 3. So all we have to do now is compute the minimum of two integers, minus 3, and x n minus 1, where n is 3. So x of 3 minus 1 is x2, which is 2. So now we're going to try and calculate the minimum of minus 3 and 2. And when we do that, we get another call to min2 where x0 is minus 3 and x1 is 2. Of course, we know that the smaller of those is again minus 3. And so that's the value that is going to be returned to this copy of min. It says that the minimum, the min2 of minus 3 and 2 is minus 3. So this min is now ready to return minus 3, which is the overall minimum of the whole array. We're now about to quit this last min and go back to the main, where we will print this minus 3 in the next step. There it is, and that's the end of the main function. So I know this is tricky. I know this requires lots of practice. So we're going to take a look at some more recursive code as well. But I wanted to give you this interesting example of calculating the minimum of n elements, whatever n is. So as usual, feel free to edit this code. If you want to make a bigger array, you'll have to make two changes, or rather 3 changes. You'll have to change this number from 3 to, let's say, 5 or 10 or whatever you want to make it. But whatever number you make here, please remember to make that same number here, because this is the length of the array. And then you have to put the appropriate number of values, integers, inside this array. Don't forget to separate them with commas. Have fun experimenting with this code, and we will go back and look at more recursion in the next few lectures.